Hello, today we are going to learn about signed distance fields and create an effect like this. So let's jump into Houdini. This is where we left off last time, and we created this volume using Vex code. And first of all, I'm going to do some small modifications to these formulas. You can see that we are comparing the formula here with another formula, and it's easier to use if you compare with 0. So I will move this z squared up here, so plus z squared, and then we can compare with 0, and you can see that we have the same result. So you can see we have a formula, and we compare that if this formula is less than 0, then we set the density to 1, otherwise it's 0. So let's do some analysis on this. So let's go back to this level, and now we can visualize this volume using a volume slice. So press tab and type volume and slice, and then connect this to the volume, and then visualize this result. So here you can see that inside we have red and outside we have purple, and this is using infrared visualization. And red means the density 1 and purple density 0. So this, I think, is easy enough to understand. So let's do some more analysis on this. So we can add a volume analysis. So press tab and type volume analysis, and then put this between. And now you can see, if you display this node, we have, for example, the curvature, and this you can use to model interesting geometry, for example. And we have something called a gradient and Laplacian and detect edges. So detect edges, as you can see, just detect the edges of this volume. And if you look at the volume slice, you have the edge here. So then what about signed distance fields? So let's go back to our Vex snippet inside this volume VOP and inside this snippet. So press P, and if you look at this, we have a formula that evaluates to a value, and we compare to 0. And then if it's negative, then it's inside, and if it's positive, then it is outside. So let's just output this value, it's the formula itself, instead of the comparison. And let's go up and look at the volume. So here you can see we have the negatives are disappearing, and then the positives are more opaque. And if I hide this, disable the volume analysis and do a volume slice, then we can see that we have in effect the distance to the surface in different colors. And this is not actually the distance, because if you look at the formula, you can see we have x squared, y squared, z squared. So this is more or less the squared distance, but still we can use it in the same way. Okay, so if we do want the real distance, then we can insert a normalization. So if you press tab and type SDF, then we have something called a volume SDF, and this will take this SDF field and normalize. So instead of the squared distance, we have the linear distance. So now each point contains the distance to this surface. But we are going to use this formula we had instead of normalizing. So I will disable this node. Okay, so this is interesting. So let's continue analyzing this. So enable the volume analysis again. And here we have something called a gradient. And this will generate a vector field that, if I disable this, will point in the direction away from the surface or towards the surface, depending on if you are inside or outside. So let's visualize this vector field. So I will go back to our volume analysis and enable this. So now we have a gradient field. And to be able to see this, I will scatter some points because we have a lot of very small voxels here and this is too much. So let's press tab and type scatter. And then I will scatter points on this plane and look at these results. Now we have fewer points compared to this. And this will be less heavy to work with. So next I'm going to add a volume trail node. So press tab and type volume trail. And on the left side I will connect our points, and on the right side the volume from the volume analysis. And this will then show the vector field on the plane of our volume slice. So we can change this plane and view the vector field on other planes. Okay, so you can see that this is going to continue leading into fluid dynamics eventually. But let's continue. So if we take, for example, this field, then you can see that this flow here is kind of colliding with itself. So if we follow one of these lines and then it goes here and stops, and if we follow the other line, then it goes here and it stops. And also if you come to the edges, then it stops. So this means that it is divergent, that it is not continuously flowing in that direction anymore. And this is something we can see if we look at the divergence. And this is also an important concept to understand in fluid dynamics. So let's change this volume analysis and view the Laplacian. And the Laplacian is basically, actually let's create a new volume analysis. So here I'm going to press tab and add another volume analysis. And this one will be now the Laplacian. And then I will add the volume trail after. So tab and volume trail. And then look at, volume slice. So let's tab and volume slice. And let's look at the Laplacian. So here we can see that the red area is where we have a continuous flow, and the purple area is the divergent points. So if you have a flow that continues here and then stop, and then you have the purple, and this defines the divergence of this vector field. And for a fluid movement we can have no divergence, so we would have to remove this divergence. And this is something we are going to do in later lessons. Okay, and I think this is enough about divergence. So let's see if there is something else here. So now we understand the gradient and the Laplacian and edges, and curvature is just what it sounds like. So let's remove these analysis parts now. let's go back to our signed, we don't need this either. So now we have a signed distance field. And you can convert this to geometry. So if we press tab and let's try ISO surface. See if this will work here. Actually, let's skip this one. Let's use instead volume convert volume. Okay. And show this. And this will find the 0 points of the signed distance field and then create a mesh around that. And depending on if negative values are to be seen as inside or outside, and that depends on the context you're working with. So if you get the wrong result, you can just invert here. And now it will take anything that is negative and make that the inside of this mesh. And then we can change what value should represent the surface. So if we say -1, then where the field has the value of -1, it will create the mesh. So then we get something smaller, and we could increase this to -0.5, -0.75. Oh, sorry, -25. And if you animate this, then you will get the result that we just looked at here. And if you want to render this out and get this glow effect, you can watch my ROP lesson on how to do that. So I hope this was helpful, and see you next time. Over and out.